Board. Hello, good evening, everybody. Welcome to our toasty technical Tuesday evening. I know everybody's feeling a little chilly around the country. Some of us are still sort of in short sleeves for a short while at least. But it's good because wind is bringing in new season and new changes, and spring is just around the corner, even though it doesn't feel like it, I'm sure. So we finished our one subject, which was weight management, that we finished up last week. And this week, maybe it's a little bit back to front. I probably should have done it the other way around. But I thought I'd cover the topic of our digestive system. And yeah, as we've said in the past, diet is what you eat. Nutrition is what your body can absorb. And it doesn't matter how healthy your diet is, if you're not absorbing the food, it's not really helping you. So our digestive system is crucial to getting that food, that nice piece of steak or lamb chops as we had tonight, broken down into usable bits that your body can utilize and take from the food the nutrition, the protein, the amino acids, the vitamins, the minerals, etc., and let your body use them the way that it is supposed to do. Obviously, when we take supplements, we tend to short circuit that whole system to a certain extent because we swallow the supplement and it gets digested and processed relatively immediately without having to be broken down at all. But we're going to cover and see exactly what is the digestive system. We talk about the digestive system, but what is it? Where in the body does it feature? So let me share my screen. I will tell you that this is, I borrowed the first part of this talk from a university, and it might be a little bit technical, but I'm going to try and keep it not so technical and user-friendly, because that's just how I like to do things. Not everybody is medical, and even I get confuzzled with some medical highfalutin, higher grade things at times. So let's start off over here. And so you'll see this is a little bit more active because I didn't do the first part. I simply borrowed it with thanks. So the digestive system. And these are the people that did most of the hard work for the technical bit in the beginning. And then I did the other bits as we go along. You'll see where I kick in as well. So the first part are compliments of these authors. And thanks to their hard work, we're going to have a little in-depth study on the digestive system and the different parts of the body that support the digestive system. The digestive system starts here in your mouth and ends at the other end. I'll let you do the maths. So the digestive system consists of the mouth, the esophagus, the stomach, the small and large intestines, the liver, the pancreas, the gallbladder, the colon, the anus, the salivary glands, the chemical digestion, and the mechanical digestion. So pretty much everything from your mouth right the way down comprises of the digestive system. Let me move my picture out of the way because I'm sure it's blocking your way there as well. So this is a little bit more of an up close and personal picture of what your mouth is. It's not just the happy smile that you see. We've got the salivary glands at the back and underneath the tongue, and there's a little duct over here that comes in and releases it all over the tongue. And there's a whole lot of other fancy technical terms which you really don't need to get involved with at this stage. So, but we'll start with the mouth, which is, we'll start the digestive system. Technically, the digestive system is an external organ because it has an opening at the top and an opening at the bottom. The fact that it runs through the middle of the body, well, that's just how it works. So the mouth helps to break down the food, which helps it to be digested in the body, because we don't, hopefully, have a piece of steak or a fish and put it in our mouth and swallow it whole. We start to chew it. We all know that we need to chew our food well to get it broken down and to swallow it easily. So the mouth produces the saliva, which breaks down the chemicals in the food to a certain extent, and which makes the food mushy and easy to swallow. Some of these descriptions might sound a little bit gross, but that is exactly how our body works. So the saliva is an essential part of the immune system as well, of the digestive system as well, and it starts to break things down. And if you are familiar with snakes, hopefully I'm not digressing too much, but snakes' venom is the same as our saliva. The only difference is their venom is toxic and ours isn't that toxic, but the venom is used to start to break down their food because they don't have teeth like ours. It works in a slightly different manner, but saliva is the first part of this whole deal. We then go to the esophagus. Please note that I'm simplifying this whole system. And if you want to know the more in-depth, well, we can do that, but I really don't think it's necessary. And Jenny would know how this whole deal works because I know she had to study this when she was doing a paramedic course. But we go from the mouth into the esophagus. And there are different ways of spelling this. This is the American spelling, just by the way. So the esophagus is the part that goes from basically the back of your throat down to the top of your stomach. It's a long, thin, muscular tube that connects the pharynx, which is a fancy word for the throat, to the stomach. And food and fluids are propelled through the esophagus into the stomach. So the esophageal sphincters normally prevent the contents of the stomach from flowing back into the esophagus or throat. So there's, let me see if I can get my cursor over here. There's a little sphincter or valve essentially just over there at the top of the stomach. And that stops, so that makes the food go on a one-way trip down and then it doesn't come back because that can get decidedly uncomfortable when it does that. So you'll see there it starts. In the pharynx, the food goes down and it goes through this little one-way valve and then into the stomach from there. And you don't want this little one-way valve to become a two-way valve because that makes life very, very uncomfortable for you. And then we get into the stomach. And the stomach is this little football thing that sits over there. And we all know that it swells or shrinks as dependent on what we put into it. So you'll see there's the esophagus going through a little valve again into the stomach, which is, think of a set of bagpipes. They can be really flat or they can be really big, depends on what you're putting into them. And our stomach does much of the same thing. It can be really flat, it can be really full, or it can be really, really full and big. Really depends on what you put in there because it can stretch, fortunately. And the stomach is, technically, it's a muscular sac that lies between the esophagus, this part over here, and the small intestine, which is this part here, which is in the upper part of our abdomen. And the stomach releases acids and enzymes for the chemical breakdown of food. As I said, we need to take this nice piece of good-looking food from the solid piece that we're holding in our hand or on our plates, and we've got to break it down into something that the body can use. And it can also expand to temporarily store food. If you've ever watched a squirrel or a hamster, you see they tuck things into their cheeks and the cheeks expand out. Well, our tummy does more or less the same sort of thing. And it is important for churning food into a consistency that is easier to digest for the rest of the body systems. So it breaks everything down. I know this is just after supper and it sounds a little bit gross, but bear with me on this one. So we've eaten the food, goes into the tummy, it's broken down into this paste, which is known as chyme, or as John Miller says, chyme. It depends which part of the ocean you happen to be on. But that's what is there in the stomach, which then gets broken down further into things that our body can use. So from the stomach, we go into the small intestine, which absorbs about 90% of the nutrients from the food we eat. So the stomach essentially is a storehouse and where things get broken down. And the small intestine is where the real action starts to happen, because that is where the food is processed or assimilated into something that our body can recognize and use. The small intestine is called small because the diameter or the width of the tube is much less than the large intestine. Doesn't mean to say that it's shorter or anything else. It's just the diameter is different. The smaller intestine is the location in the body where the majority of the nutrients from ingested food are absorbed. Digested food passes through the wall of the intestine into the blood vessels, which then distribute the nutrition first to the liver and then through the rest of the body. So your liver is a filtration system that filters out all the toxins, basically. And that is what the inside of you looks like in a healthy person. Sometimes doesn't look quite as healthy as that, but generally this is what it looks like. So you can see there's the liver, the gallbladder, the stomach. We won't worry about all the other fancy terms, but small intestine and large intestine going down to the other end. So the small intestine consists of these fancy words called the duodenum, the jejunum, and the ileum. Please don't stress about all these fancy words. That's just there to make medical people sound really intelligent. That's the small intestine. It's all that we really need to know about it. So now we get to the large intestine, which is a little fatter and a little smaller than the small intestine. In other words, it's a little shorter. And it performs the vital task of absorbing water and vitamins while converting the digested food into waste, which eventually gets processed out the other end. And as your body takes back water, it just leaves the waste products behind. And these become drier and harder, so it is easier for your body to get rid of them. Again, my apologies for the grossness, but this is how our bodies actually work. So all your food goes in here, it's broken down into this large intestine over here, that then starts to separate well, most of the usable stuff has been sorted out in the small intestine, and then the last 10% gets processed through the large intestine and broken down into the vitamins and the waste products, where it gets separated. And like the really intelligent little system that our body is, it doesn't like to have all this waste just sitting around, so it gets rid of it. And that's pretty much how it works over there. Again, fancy words, don't stress about it. It's just inside that is there. And sadly enough, we tend to have a lot of issues with our digestive system if we don't eat correctly. And if the digestive system fails, I can tell you, you're going to be very, very uncomfortable. So now the liver. The liver plays a role in the process of digestion through the production of bile. Bile travels through the bile ducts and is released into the duodenum, where it emulsifies large masses of fat. So think of that nice fatty meal that you had last, big piece of steak, well-buttered piece of fish, fried eggs, etc. And the fats made by the bile turns the large clumps of fat into smaller pieces that have more surface area and are therefore easier for the body to digest, because you don't want this fat to back up and to putrefy basically, and then cause further problems. That is where your liver sits. So it's just the top end of the abdomen, just under the, just below the lungs, basically. The liver is quite a fascinating little thing. Now, this little guy here, this little green sac, is the gallbladder. And people with bad diets end up with bad gallbladders. And I happen to see these patients on a regular basis. And I get to see what gets taken out of these gallbladders at times. I can tell you, it is definitely advisable to make sure you have a good, clean diet. I have one particular surgeon that I work with, and he does gallbladder removal procedures, probably on average at least one a day. And so I see a good 4 to 5 people who've had their gallbladders removed every single week in numerous different hospitals just down here. You can live without your gallbladder, by the way. You now have to drastically change your diet because you're not going to be able to process the heavy fats quite as easily anymore once your gallbladder has been removed. But that's for another talk. We won't get into that tonight. Then the pancreas. And it's a part of the digestive system and produces the important enzymes and hormones that help to break down foods as well. So we have the gallbladder and we have pancreas. Now the enzymes or digestive juices produced by the pancreas are secreted into the small intestine to further break down food after it has left the stomach. And it has an endocrine function because it releases juices directly into the bloodstream, and it has an exocrine, so endo meaning inside, exo meaning outside, an exocrine function because it releases juices into ducts. So it's quite a complex little gland, this. And that is where you'll see it. It's just below the gallbladder and sitting around near the liver and the large intestine. Small intestine, sorry. So it all sits in this little area here. And people who consume a lot of alcohol will end up with problems with their liver and the pancreas. And if you have issues with either your liver or your pancreas, you are not going to be a very happy camper. One of the more common problems that I see is when alcoholics, for want of any better definition, land up in hospital. They end up with what's known as pancreatitis, which is an inflammation of the pancreas, and they are not happy campers. And the way that they treat it is not very pleasant either. I think patients who undergo these procedures wish they'd never ever seen alcohol in their lives before. Sadly, by then, it's a bit late. So the gallbladder is this little guy over here, as I said, and here's the guy that gets removed if it gets full of gallstones, which can look anything like a river pebble to a whole lot of fine gravel. Either way, people who've had these problems are not happy campers. It's a small storage organ that is located inferior, which is down, and posterior, which is back to the liver. So it's below and to the back of the liver. It holds bile, which is produced in the liver, until it is needed for digesting fatty foods in the duodenum of the small intestine. When food enters the small intestine, a hormone called cholecystokinin is released, signaling the gallbladder to contract and secrete the bile into the small intestine through the common bile duct. So the procedure that is done when the gallbladder is removed is called a cholecystectomy. We just call it a chole. And if you have an inflammation of the gallbladder, it is known as cholecystitis. Again, the itis part is inflammation. Fancy terms, don't stress about it. And that is another little picture of what your gallbladder looks like. So again, think of like a little bean pod, I suppose you could liken it to. And this is now the colon that we're going to be talking about, which is also known as the large intestine. So we have this is medical terminology that's actually quite simple. We have the ascending going up, and we have the transverse going across, and the descending going down. And then we've got a couple of other fancy terms over there because people ran out of fancy names. Now, liquid and salt is removed from the waste as it passes through the colon, and gets rid of the food that's left over after the nutrients are removed from it, the bacteria and other waste. So after all the good stuff has been taken out of the food that you had on your plate earlier, we are now left with waste. And that goes through your colon and goes out the other end. Now, this is another common little organ that often gets us into trouble, called the appendix. Back numerous years ago, doctors used to say that the appendix was there in order to pay for their kids' university fees, along with the tonsils, because they were simply removed at a certain age. They have now since discovered that the appendix and the tonsils are actually quite important parts of our immune system. So the anus, which is the opening at the far end of the digestive tract, through which the stool leaves the body. So it's the external gate, basically. And it acts like a gate that allows the waste to exit the body. And sadly, there's also quite a few problems that develop in this area. We're not going to get into that just yet. So the salivary glands, we're going to go back from the bottom to the top. And they produce saliva, surprisingly enough, which keeps the mouth and other parts of the digestive system moist. And I know sometimes people complain about a dry mouth. I can tell you that people who have had radiation in the mouth, throat area often have their salivary glands destroyed through that radiation, and they have to be given artificial saliva. It is extremely difficult, if not impossible, to actually swallow food if you do not have adequate saliva. And it helps, the saliva helps to break down carbohydrates. It lubricates the passage of food down from the oropharynx, which is oro meaning mouth, pharynx is the throat, to the esophagus, to the stomach. Because dry stuff is not going down, we need it to be lubricated. So we've got 3 different sections where there's salivary glands, and they all work together to produce the stuff in your mouth that causes everything to go down quite easily. Then we have the chemical digestion, which is the breaking down of the food into simpler nutrients that can be used by the cells. As I said, we've got to take the food that's on our plate that looks good and tastes good, but we've got to be able to turn it into something that now does good in our body. It begins in the mouth when food mixes with saliva. The enzymes necessary for proper chemical digestion are now in equilibrium. Nature likes everything to be in equilibrium. Then you have your mechanical digestion. And this involves physically breaking down the food into smaller pieces. Mechanical digestion begins in the mouth as the food is chewed. So you're not going to just swallow that big piece of fish or chicken or steak. You have to chew it to break it down. And these are how the food is broken down physically. It starts with the mouth and combination of actions between the teeth, the tongue, and the palates, your hard and your soft palates. Goes into the esophagus, and by a system called peristalsis, which simply means moving up and down, goes into the stomach, where there's a muscular churning action of the stomach, and then gets turned into bile through peristalsis. And Neolife, just by the way, do such a thorough job at seeing how this whole system works and studying how this whole system works, that they actually designed and invented an artificial stomach that mimics the exact way that food is absorbed, broken down, and processed right the way through the small and the large intestine, so that they can see exactly how food is processed, as well as how our supplements are processed. I think it's pretty unique amongst any nutrition company in the world. Now, the difference between mechanical and chemical digestion, remember, this is a talk that I borrowed from the university, so they're getting a little bit technical over here. So we need all these nice sharp teeth and the tongue and everything over there to do the mechanical digestion, and then we process it down into chemical digestion to go into the small intestine. And how did the digestive system maintain homeostasis, or fancy word for equilibrium? The digestive system maintains homeostasis by creating the proper pH balance in the gastric environment. In other words, not too much acid, but not too little acid. In addition, by maintaining the correct enzyme ratio, the digestive system nurtures the beneficial bacteria that inhibit disease and produce biological substances the body needs, such as vitamin K. Remember, we've got good and bad bacteria in our system, but we need more good bacteria to inhibit the disease than the bad bacteria that causes the disease. So we've got to keep everything in balance. Nature loves balance. And so how does the digestive system affect the other body systems? The digestive system distributes the nutrients to the rest of the body systems. So if your digestive system is not working, the rest of your body is not going to work properly either. And this provides the system's energy to keep on working, which is why you have energy to do daily life activities. For example, the digestive system works in parallel with the excretory system, while the digestive system collects and removes undigested solids. The excretory system filters the compounds from the bloodstream, collects them in urine, and they are closely connected in controlling the amount of water in your body. So, as I've always said before, too much of anything is bad for you. Too much water is bad for you, same as too little of anything is bad for you. And how the other body systems affect the system, the digestive system, other body parts help give the ability of the digestive system to digest the food. Both certain bones of the skeletal system and muscles of the muscular system are involved in chewing food, namely the jaws, the teeth, and the muscles in the jaw, as well as the tongue. The muscular system also plays an important role in swallowing food and moving the products of the digestion process along the gastrointestinal tract. The endocrine system interacts with the digestive system in that there are hormones that play a role in the digestive system. And the functioning of the nervous system can also have an impact on how digestion progresses. So nature loves to have everything working together. The two diseases of the system, we have a thing called a gastroesophageal reflux disease, or GERD, which is otherwise known as severe heartburn in layman's language, which is a weakness of the valve between the esophagus and stomach, which may allow stomach acid to reflux into the esophagus and irritate and inflame the lining. This results in chest pain, which can mimic that of angina. And jaundice is a yellowing of the skin and whites of the eyes from a backup of bile metabolic byproducts from the blood into body tissues. It may result from blockage of the ducts draining bile from the liver into the intestines, or excessive breakdown of red blood cells. hemoglobin, which are the red blood cells, from destroyed, or hemoglobin, which is basically iron, from the destroyed red blood cells is broken down and in part ends up in bile secretions. So the effects of outside or environmental factors on the digestive system. Stress is number one. And stress is something that is a major, major problem these days. So stress has the opposite effect on your digestive system. My apologies for the slowness over here. So stress causes all sorts of grief. For some constitutions, it can cause a lot of other issues. It causes food to move too quickly from the mouth into the stomach. Should have been slightly faster, my apologies. And basically, you aren't able to digest your food correctly. So you eat quickly, you swallow, but it's not having time to digest and be processed through the system. Therefore, we're not getting sufficient nutrients to give our bodies the nutrition that it needs because it's not being absorbed. You can have a great diet, but remember, if you're not absorbing it, it's not doing anything good for you. It leads to nutritional imbalances or deficiencies. I'm going to speed this up a little bit. The negative effects of drug abuse on the digestive system are due mainly to the deterioration of the mucous membrane lining that runs through the entire GI or gastrointestinal tract. The mucous membrane helps to break down food in a process called peristalsis. When this lining is damaged, it leaves areas like the intestine and stomach walls vulnerable to damage and more serious ailments. So overeating can slow down the digestive process, and the food we eat remains in the stomach for a longer duration of time. And what happens to food if you leave it out on the kitchen counter for an extended period of time? It starts to break down and becomes poison. This is exactly what happens in our gut. So 3 quick fun facts about the digestive system. When you eat something, food doesn't simply fall through your esophagus and into your stomach, fortunately. The muscles in your esophagus constrict and relax in a wave-like manner called peristalsis, pushing the food down through the small canal and into the stomach. Because of this action, even if you were to eat while hanging upside down, the food would still be able to get to your stomach. So will water, for that matter. The stomach is an integral part of the digestive system, but it's not the same in all animals. Some animals have stomachs with multiple compartments. They're often mistakenly said to have multiple stomachs. So cows and other ruminants, including giraffes, deer, and cattle, have 4-chambered stomachs, which help them digest their plant-based food. And I'm going to stop right there because I know we are running low on time. We've got about 4 minutes left. Stop sharing. Does anybody have any questions in this last 3 minutes or so? Please unmute yourself before I stop recording.
Sean,
yes.
if I can just ask a question.
Mm.
When you get bloating,
yes.
So the gas in your stomach doesn't pass through, but it causes your stomach to extend.
Correct.
And I know in cattle and sheep, when there's stomach like that, you use a thing called a trocar, where you actually pierce that and allow the gases to come out.
Yes.
What causes that lot? Why is it not going through?
It's basically what's happening is that, especially in animals, they've had too much green stuff. And now there's a buildup of bacteria in the gut. And that bacteria gives off a gas. And because of the way that their stomachs are designed, specifically in animals, they can't get rid of that gas in a hurry. That's why they've got to be, the process has to be mechanically sped up. Our system works slightly different, and we generally can get rid of the gas, but if necessary, they can do a surgical incision, similar thing to the trocar, to release that gas. So the bloating happens because there's a buildup of food that has not been broken down correctly, and that leads to an overgrowth of bacteria, of bad bacteria, which leads to the gas.
No,
and then the bloating.
that makes sense. Thank you.
Okay. All right, let me stop recording.
Sean, will that happen if the food is not chewed properly?
Correct. So if you're not chewing food properly,
when you eat like in a hurry, kind of thing.
Correct. So these fast foods, you're not eating properly, you're not chewing properly, you're swallowing the food whole. And the other thing is, if your acid system in the stomach is out of whack, so your pH is off, you're going to end up with a problem there as well. So in some cases, some medications will cause you not to have sufficient acid to break down the food, or with stress, you tend to have too much acid, which also causes an imbalance in that digestive process.
Sure, that's interesting.
Which is why it's so important to chew properly and stay away from stress.
I remember some time ago, years ago, Dr. Oz said people take Rennies and that interferes with the stomach acid.
Correct. It neutralizes it too much. Right.
Thank you very much, Sean.